Hello everyone, welcome to Dr. Ravi's Academy. In today's virtual class, you will be understanding how to calculate the mass moment of inertia of a slender rod about one end perpendicular to the axis, that is first bit, and about the central axis, central x and y as well as z axis. So let us look at this problem. Here, the first figure is assume that it is about y axis, the slender rod is revolving, which is the axis perpendicular to this, and let us select an element at a distance x from the y-axis, and the elemental mass is dm, and elemental length is it is dx. Elemental length is dx, and the definition is y is equals to integral, it is x square dm, and let us consider m is the total mass, which is equals to mass per unit length into total length. So let us calculate the elemental mass dm, which is m times it is dx, and substitute that you have it is x square, m is constant, integral it is dx, the limits of integration 0 to l, 0 to L. Now the x square integration is x cube, and it is m times it is x cube by 3, and the limits are it is 0 to L. You can substitute this m into it is L cube by 3. This you can rewrite as ml into L square by 3, and as you know ml is nothing but total mass, it is m into L square by 3. So this is the mass moment of inertia of the slender rod about one end, that is your y-axis. Second bit, let us look at this. The second bit is central axis. So just observe carefully. About x-axis, Ixc is 0 because the cross-section area is very small when compared with the length of the object. So moment of inertia, assume that it is revolving about x-axis, so it is 0. And again, let us see that it is Iyc is equals to even it is Izc. So let us calculate Iyc, so that which is also equal to Izc. So Iyc is equals to it is integral x square dm, and as you know that it is a dm, you can replace with the m into dx, and here integral x square dm is m dx integral. So m is constant, you can keep outside, that is x square dx, and observe carefully the limits of integration minus L by 2 to plus L by 2. So that you can write down 0 to L by 2 by multiplying with 2. This becomes 2m, it is L, it is by 3, x cube by 3. So you can write down 3 outside, and it is L by 2 cube. So it is L cube divided by 8. And you have 2 fours, and it is ml into L square by 12, and this value is ml square by 12 is the answer. The moment of inertia of Iyc, which is also equal to Izc, and the moment of inertia of this particular slender rod about x-axis is 0, and y as well as z-axis is ml square by 12. Thank you for watching this video.